everyone, welcome back to my YouTube channel. I'm Miss Merkin. So today what we're going to be talking about is reference angles and how we can actually use reference angles to help us evaluate trig functions when they're not nice and pretty on the unit circle. This actually enables us to not have to memorize the entire unit circle as well, which is really nice. Okay, so first off, when we are using reference angles, we first need to know how to plot or remember how to plot an angle on a graph like this. So we always start on the positive x-axis. This is our 0 degree point, okay, or 0 radians. Then we, so this is almost like the first part of your angle, okay? Then we have what's called the terminal side, which moves, and it opens up to however wide you want your angle to be. So we have 0, this would be 90 degrees, or if you want to do radians, it's pi over 2. Okay, then we have 180 degrees over here, which would be pi. And then we have 270 degrees down here, which would be your 3 pi over 2. Okay, and then we have some stuff in between. So let's say I want to, I have theta, and I want to graph theta, which is, let's go with 120 degrees. Okay, so I'm past 90 for how much I'm going to open my terminal side up to, but I'm not quite to 180, okay, so I'm about here. Okay, so theta is 120 degrees. And so this angle right here I've drawn, actually I'm going to draw it in a different color so you can see it a little bit better. So right here for my 120 degree angle, I have my initial side. And for my side that moved and opened to where I wanted it to open, I have my terminal side. Okay, now I have 120 degrees here, which is on our unit circle, but let's say I didn't really memorize quadrant 2 of the unit circle, and I want to evaluate sine of 120 degrees, but like I said, I didn't memorize that part. I only memorized the first quadrant. So I could actually use what we call a reference angle. Now, our notation for the reference angle of this theta is theta with a little line over it. That equals our reference angle. So how do I find a reference angle if I already know that my original theta is 120 degrees? Okay, so to find a reference angle, your reference angle is the shortest distance from the x-axis. Note, I just said x-axis. I didn't say positive x-axis. I didn't say negative x-axis. I just said from the x-axis. So the shortest distance from the x-axis to that terminal side. So it's a long ways for me to go from this initial side all the way to that terminal side. So if instead I went from the negative x-axis up to my terminal side, I don't have to go as far. So my reference angle, which I'm going to use a different color for, I'll use pink. My reference angle right here, okay, would be 180 degrees minus 120, okay? So my reference angle would be 180 degrees, whoops, minus 120 degrees, okay? So, our reference angle, so 180 minus 120 is 60 degrees. Okay, so that is how you find a reference angle from a given angle. Okay, so next I'm going to do an example where I'm given a couple of trig functions with an angle to evaluate at that's not quite obvious to use for the unit circle. Okay, so now I'm going to show you two examples of how we can actually use reference angles to to solve our trig equations. So right here I have cosine of 210 degrees. So I'm going to draw my original angle first. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees. I'm in degrees, so I'm just going to keep it in degrees. Okay, so 210 degrees, I'm starting at my positive x-axis, and I'm opening my angle up to 210 degrees, which would be about there. Okay, so I have this big angle, but I don't want to use 210 degrees. I don't remember all of the quadrants on the unit circle. I just really only know the first quadrant. So what I'm going to do is use a reference angle. So it's the shortest distance from the x-axis. So instead of going from the positive x-axis, I'm going to go from the negative x-axis down to my terminal side. I'm going to show you where that is with a different color. So I went from the negative x-axis to my terminal side, and I have this reference angle. Okay, so theta, with the little line over it to show that that's my reference angle. My reference angle is, let's see, so we're going to have to do, we have 210, okay, minus 180. Okay, so it looks like our reference angle is 30 degrees. Okay, now I can evaluate cosine of 30 degrees. Okay, so one thing that we need to kind of remember is that when you do look at your unit circle, or you might have this memorized by now, it's up to you, our x coordinate is always cosine of theta. I don't know if you can see that, so I'm going to write it a little bigger. So when we have our coordinates x, y, our x is cosine of theta, and our y is sine of theta. So we're looking for the x coordinate, okay, on our unit circle at 30 degrees. I'm looking up here, and it's root 3 over 2. Like I said, some of you have this memorized. So cosine of 30 degrees is root 3 over 2. Now, that's not what cosine of 210 degrees equals necessarily. It might, but I have a feeling it's not quite that. Now, it's equivalent in value, in absolute value, but it might be negative. And the way we find out is, well, depends what quadrant our original angle is in. Let me actually change colors so that this doesn't get super confusing. Okay, so if we're in quadrant 1, both cosine and sine are positive. If we're in quadrant 2, okay, cosine's negative and sine's positive. If we're in quadrant 3, okay, they're both going to be negative. And if we're in quadrant 4, okay, we have cosine, which is positive, and sine, which is negative. Now, 210 degrees is in quadrant 3. We're doing cosine, so in quadrant 3, cosine should be negative. So it's going to be root 3 over 2, but we need to have that negative sign in front. So equals, and I'm going to do a little color change real quick, negative root 3 over 2. So that's our last step if you want to use a reference angle to evaluate a trig function, is we have to check the sign to see whether it's positive or negative based on whichever quadrant your original angle was in. Okay, now I have tangent of 4 pi over 3. So we're switching gears a little bit, and now we're doing radians, which is okay. So we're going to draw our original angle first. So I have tangent of 4 pi over 3. I'm going to label this guy right here. So I have 0 radians. This would be pi over 2 radians, pi radians, and 3 pi over 2 radians. Okay. So I have 4 pi over 3. So I'm starting at my positive x-axis. And let's see, well, this pi right here is really the same as 3 pi over 3. This would be well, 9 pi over 6, that would be 8 pi over 6, that's a little bigger. So I'm going to end up somewhere, once again, in that third quadrant. Okay, so this is my original angle right here. Okay, it's a wide angle. Okay, but I don't want to use that huge angle. I want to use a reference angle because, once again, I only really know the first quadrant of my unit circle. Okay, so that means I'm going to go from my negative x-axis now, because that's going to be the shorter distance, okay, down to my terminal side. Okay, so this angle right here is going to be my reference angle. Okay, so let's calculate what that is. Okay, so our full angle is 4 pi over 3. But I don't want this whole pi right here, I just want this little sliver. See what I did there? Okay, so I'm going to subtract pi. I'm going to just change pi to 3 pi over 3, still equivalent. Okay, 4 pi over 3 minus 3 pi over 3 is pi over 3. So that means I'm going to find tangent of pi over 3. Now, tangent is not a coordinate on the unit circle, but we can use the fact that tangent of theta, I'll write this up here, equals sine of theta over cosine of theta. Okay, so that means I can just take whichever coordinate is at pi over 3 on my unit circle and create a ratio of, well, sine of theta is equal to y, so y over cosine of theta is equal to x. So let's go find that. So pi over 3, my coordinates are a half, comma, root 3 over 2 right here. Okay, I don't know if the camera can quite see that, but a half is my x coordinate and root 3 over 2 is my y. So this equals y over x, so root 3 over 2 over 1/2. Okay. To divide fractions, we multiply by the reciprocal. So it's root 3 over 2 times 2, which 2 divided by 2 is 1. I'm just left with root 3. Now, note that this is positive. This is going to be in absolute value root 3, right? But we need to check to see if it's going to be positive or negative. Well, this is slightly trickier to figure out, but not too bad. So both our sine and cosine is negative in quadrant 3, which is where our original angle is. But if I divide, see it's y over x or sine over cosine, if I divide two negative numbers, I get a positive number. So tangent of 4 pi over 3 is just going to be equal to just positive root 3. All right, and that is it. That is how you can use a reference angle to evaluate a trig function at a given angle. And it's a little nicer because you don't have to memorize the whole darn unit circle by using this method.